Let's take a look at some more examples that require us to use our counting methods in order to calculate probabilities. Our first one says, what is the probability that if 10 letters are typed, no letters are repeated? Okay, so we have 26 letters in the alphabet. If we don't repeat them, that means 26 choices for the first one, 25 for the next, 24 for the one after that, 23, etc., until we get down to our 10th letter where we would have 18 choices. It's kind of tedious to write out, but it works. That's just using our fundamental counting principle. Then that's the number of favorable outcomes, 10 letters, no repeats. We need to divide that by the total number of outcomes. Well, the total number of outcomes is 10 letter words with repeats. Well, if we repeat, that means it's 26 times 26 times 26, etc., down to 26, 10 times. There's a much shorter way to write this, and that would be the top, the permutation of 26 things, 26 letters, taken 10 at a time. And we use a permutation here because the order does matter, and because we're not repeating. There's no repetition of a letter. The bottom, though, would be 26 raised to the 10th power, right? Because it's 26 times itself 10 times. We would use our calculator to get our answers here, and when we do that, we should come up with about 0.137 or 13.7% probability. Let's take a look at another. This one says we have a jury pool that consists of 27 people, 14 men and 13 women. Compute the probability that a randomly selected jury of 12 people is all male. Okay, well, again, I'm looking for the number of ways I can get a favorable outcome, 12 men chosen for this jury, out of all the possible juries that we could have. So for the first one, I'm looking at number of ways to get 12 males out of the 14. Right, you have 14 to select from, and how many different ways can I choose 12 of them? And then for the bottom, it's how many ways can I choose 12 out of the entire group of people, which is 27. Well, I'm choosing a group. I really don't care the order here, so this is going to involve combinations. So the top would be the combination of 14 men taken 12 at a time, divided by the combination of 27 individuals taken 12 at a time. And again, we'd use our calculator to come up with the answer here, which is going to be, on my calculator, 5.2 with a -6, meaning 10 to the -6. Well, what that means is we're going to have to move the decimal point over 6 places to the left and come up with 0.000052. Really small probability on that one. Okay, one more. This one involves a deck of 52 cards, a standard deck. We want to find the probability A, that all 3 cards drawn at random are queens, B, that all 3 are clubs, and C, that all 3 are odd. And we're not going to consider the ace as a 1. We're just going to use the numbers that are normal, the 3, the 5, the 7, etc. So if you think you've figured out what we're doing here, go ahead and hit pause and give it a try. All right, let's see how you did. So for the first one, all 3 are queens. Well, there are 4 queens, 1 from each suit in the deck. So the favorable outcomes would be the combination of 4 things taken 3 at a time. How many different ways can we choose 3 queens out of those 4? But the total outcomes is going to be 52 cards taken 3 at a time. So it's the combination of 52 things taken 3 at a time. Again, we're using combinations here because we're just pulling out cards. We're not going to care what order they're in. So this is one of those weird ones again with a scientific notation answer, which means I'm going to have to move that decimal point over and get 0.00018. Not very likely. What about the next one? All 3 are clubs. Well, the denominator is going to be the same, but this time our numerator is going to be 13 things taken 3 at a time. We're still using combinations, so we're having more to choose from. We're going to have more possible ways of getting those 3 clubs. So our probability is a little bit higher, 0.013. Now what about the next one? Odd. So we said that would be 3, 5, 7, 9, and those are the only odd numbered cards in a deck. And we have those in each of the suits. So you would do the combination of 12 things taken 3 at a time for your numerator, same denominator. So in this one, and I want to point this out, it would be 0.00995, which if I'm asked to round to the nearest 2 decimal places or nearest hundredth, I would say, okay, the 5 rounds the 9 up to a 10, which rounds the next one up to a 10. So really, it is 0.01. Let me know if you have any questions.